Hey everybody, the name of this session is Deep Dive on Amazon MemoryDB for Redis. My name is John Fritz. I'm the Head of Product Management for the In-Memory Database and Caching Services Group at AWS, and I'm joined here by Mahesh Lagashetty, the Vice President, Data Engineering at TSYS. So Amazon MemoryDB is a new database service at AWS. It's a Redis-compatible in-memory database service with multi-AZ durability. And we're going to get into more details about the features of this database over the rest of the presentation. But I wanted to start out by talking a little bit about some of the customer input that we got leading up to the creation of this database and some of the reasons why we built it. So in the background, to kind of begin, there's several trends going on that we've seen that really underlie the need for a database like MemoryDB. The first is just the explosion of data. Every 10 years, or every 5 years, data grows 10 times, so just a massive growth of data, that customers prefer to use microservices applications in the cloud, breaking apart monolithic applications into smaller components, but thus being able to choose the right tool for the right job for each microservice. And also just the rapid rate of change driven by DevOps team, where DevOps teams move fast, but they want their components to be easy to manage and easy to use in order to facilitate moving quickly. From a microservices application, as you can see here, just there's ability to break apart these applications, making them easier to scale and develop more quickly. But this trend has also kind of led to the rise of application building teams trying to choose the right tool for the right job for each smaller underlying component, because you don't need a one-size-fits-all solution like you might have needed for applications before. Microservices, besides being able to kind of leverage the right data tool for the right job, also have more emphasis generally on hot data. That your containerized stack oftentimes has many different microservices needing quick access and high throughput, because these are the applications structure for modern applications, which oftentimes need to scale because they're underlying large consumer apps to things like IoT. So when we talked with customers, what they really asked for was, we need a new database to support hot data. And when we looked across the requirements, we kind of boiled it down, the requirements, to a fast, flexible, and friendly database. We mean fast, that a single user action in an application with microservices can kick off many microservices downstream, each with a very tiny latency budget to complete the whole action to come back to the customer input. Also, these are modern applications that need to scale. You can have millions of concurrent users with millions of requests per second. These databases also need to be flexible, that these development teams are developing at high velocity and need a flexible data model to be able to innovate quickly and build new features for their customers, and the database needs to be able to handle this rapid rate of change. And finally, it needs to be friendly, that it needs to be kind of fully managed so DevOps teams can easily manage infrastructure, and the database needs to be simple to do simple things, but also enable kind of additional complexity as well as the complexity of an application grows. So today, for high performance applications, customers oftentimes explore in-memory data stores. But there's several problems that we found, and these are some of the inputs into why we built MemoryDB. The first is these data stores can be difficult to manage. You've got to provision hardware, software, configure them, configure backups. And it can take a lot of time to get these things to work well. They're also, in critical paths of the applications. They need to be up all the time and supporting those applications. A second area, and this is probably one of the biggest areas, is hard to make these in-memory databases and data stores with today's technologies robust. That a primary database, customers come and tell us that there can be no data loss. It makes sense. It's the foundation of your application. But a lot of in-memory data technologies don't really have any semblance of true durability, where you really can have zero data loss, or being able to recover gracefully in a consistent way during an outage. And so we found that to be true, and a big problem where customers oftentimes need to use, say, a cache and a primary database to get that performance. These systems are also difficult to scale, that you need to do it in an online fashion to support an application as it grows. But doing that can be very manual and error prone also in these in-memory technologies today, resulting in data loss. Finally, they can be very expensive. If you think about all the stuff we just talked about, you need to invest in people, processes, hardware, and oftentimes software licenses to be able to utilize this sort of technology. So this was the input into building Amazon MemoryDB for Redis, our new in-memory Redis compatible database with multi-AZ durability. MemoryDB sits within our purpose-built portfolio of databases in AWS, and I really love this slide because it just shows the kind of wide variety of databases that you can leverage in the cloud in a couple of clicks to build your applications. And before going deep on MemoryDB and some of the features and how it's built, I love going through this slide just to give a little bit of the lay of the land on how MemoryDB fits within the greater AWS database ecosystem. Here you see we've got relational databases used for a variety of use cases, Amazon Aurora and RDS, MySQL, Postgres, DynamoDB for key value, DocumentDB for document data types. Our in-memory portfolio has two services now, Amazon Elasticache for Redis and Memcached, and Elasticache is meant for caching data from other primary databases and data stores, or for transient data that doesn't need to be durable. MemoryDB, on the other hand, for Redis, has multi-AZ durability and really meant to be a high-performant database that's a primary database for your applications. We've got Amazon Neptune for graph data types, Amazon TimeStream for time series, QLDB, which is a ledger database, and Keyspaces, which is a wide column database using the Cassandra API. So a wide variety of databases to really enable you to build applications. And as you can see, from a microservices perspective, you can really choose the right database for the right job, MemoryDB being if you need a primary database that's durable with incredibly high performance and that utilizes the Redis API. And we'll talk a little bit about why the Redis API and data structures Redis provides are special and make it super easy to build applications. So let's zoom in on MemoryDB for Redis. So once again, Redis compatible in-memory database with multi-AZ durability. And I want to go through a couple of the kind of main features or feature areas of this database, and then we'll kind of dive a little bit deeper into some of these areas in the subsequent slides. So first, MemoryDB is ultra-fast performance. This is the fastest database AWS has. It's got microsecond read and single-digit millisecond write latency. So that's very, very fast in-memory performance. And if you scale your cluster out, you can get up to millions of transactions per second. And so this can support the most demanding applications that have high throughput and low latency requirements. It is ostensibly 100% Redis compatible, that for all of the Redis data operations, we're compatible. There's a couple of like management operations that we don't support, but the reason is because we do all of that for you. We take snapshots, we do all of that stuff. And so you don't need to use those commands to do it because it's automated in the system. So from a Redis API compatibility point of view for, basically everything and all of the data operations and data structures, it is 100% compatible. This is important, and we'll talk about it later, that just it's so easy to build with Redis data structures and APIs, a variety of different application types. And also, if you're already a Redis user and said, well, I really love Redis, but I wish I could use it as a primary database with strong durability, MemoryDB is the perfect option for you, that you can utilize all of the same Redis knowledge, but use it in the context of a primary durable database. MemoryDB is durable and has high availability. We'll talk a little bit about how it's built in a later slide, but it utilizes a multi-AZ, so across a variety of AWS availability zones in a region, transaction log for durability. And this isn't like running on each node in the cluster. This is a separate component that underlies the database that holds data durable across multi-AZs, which is what you want if you're running a primary database. You can also create up to 5 replicas per shard, which is per set of keys in the database for high availability for that key space, and also to scale out your read performance as well. So there's a bunch of enterprise-grade options, and once again, enabling you to use Redis as a primary durable database. MemoryDB is fully managed, kind of the same set of features you'd expect from all of our top-tier enterprise-grade databases. you managing the hardware and the software setup, configuration, monitoring resources, snapshots, and a variety of other things as well, making it super easy to get started and manage the database. It's high scalability, that you can create very large MemoryDB clusters. You can have up to 500 nodes. Well, the way we like to think about it is you can store 128 terabytes of storage per cluster with one replica per shard. So that's 250 primaries, 250 replicas. If you're running a serious workload, you're probably going to want at least one replica for high availability in a different AZ. And so that's where we come up with about 128 terabytes of storage. But that's all data that is stored in memory. So incredibly high throughput, low latency on 128 terabytes of storage per cluster. And also just easy to scale in and out. We'll talk a little bit about that later in the presentation. Finally, there's a variety of security features that make it easy to configure and secure your cluster. And that ranges from supporting Amazon VPC for network isolation, encryption at rest and in transit, and using the Redis Access Control List, ACL, feature set for creating multi-tenancy on a cluster, supporting multiple users with different authorization policies. So taking a step back, MemoryDB for Redis is an ultra-fast, Redis-compatible database, durable, fully managed, easy to scale, and very secure. So if you can think about the use cases that, how as a customer would I use a fast, easy to use database that leverages the Redis API, you can imagine that it's used in a ton of different use cases that are a good fit for a database like this. From a retail point of view, storing customer profiles and account information, which you need at super low latency. Inventory tracking and fulfillment. You might have tons of updates on orders all times of day and need a fast database system to go and track all of that and serve that information. For gaming, leaderboards, which is a great example of one of the canonical examples of Redis data structures. You can use a sorted set in Redis, and without having to write any sorting code, you can just insert records into the leaderboard and return it in order, creating these kind of high-performant leaderboards just very, very easy to do. Once again, player data stores, session history, these are all things that, session history, there might be advantages to having it durable for some period of time. You can utilize MemoryDB for high performance and durability to use as the primary data stores for this. From a banking and finance perspective, user transactions, great use for a low latency database that has the performance characteristics of MemoryDB, or fraud detection, that you have something in near real time or real time, a lot of information coming in, and MemoryDB can ingest records at an incredible speed and then do near real time analytics utilizing a variety of different Redis commands to be able to detect fraud or not, or the probability of fraud. From media and entertainment, once again, more kind of user information stores that you need to have low latency for when users are coming in and accessing the platform, or real-time streaming. And finally, from an Internet of Things IoT perspective, real-time analytics on data coming in, or I actually think this is one of the cool feature of Redis, spatial lookups, that Redis has a variety of geospatial commands, making it easy to do real-time kind of radius queries and things like that to detect how close things are or how things are moving at lightning fast speed. This is just a subset of use cases. Like, once again, when you think about it, taking a step back, where can I leverage a database with incredibly low latency, high throughput, and the flexibility of the Redis data structures and data types? And there's kind of just loads of use cases across basically any industry you can think of where something like this could be useful. So in the next set of slides, I'm going to dive into a little bit of some of the attributes on performance and other features that we talked a little bit about at a higher level on the previous slide a couple slides ago. So MemoryDB, fast and highly scalable. Well, what do we mean by that? I like showing this architecture diagram on the left, kind of a high-level architecture diagram on how MemoryDB works. And we'll talk a little bit about this from a performance standpoint, and then a little bit later from a durability standpoint. But as you can see here on the left, the MemoryDB cluster has a primary and replica nodes, and those nodes are storing all of the data. And they're storing all of that data in memory. So the entire data set is stored in memory. So what does that mean? Well, that means that you get incredibly low latency, that you get microsecond read performance, the same as you would out of a cache because the data is being stored in memory. From a write perspective, it's a little bit slower than, say, a cache. That with Elasticache for Redis, we see microsecond write performance as well. MemoryDB gives you single-digit millisecond write performance. And the reason is, if you think about it, there's a little bit of a performance penalty for making those writes durable. And we'll talk a little bit about that in a later slide, but as you can probably see here as a sneak peek, a write path goes through this multi-AZ transactional log, which has extra network hop and some other things to happen before the write gets ACKed. And so that's a little bit of the driver there. But still, when you take a step back, incredibly fast performance. You could say it's a little bit more optimized for reads because you get the microsecond read performance. But we found that for a large amount of high performance NoSQL use cases, single-digit millisecond write is fast enough to meet those requirements. Also, if you think about it, you get a high throughput. And a great example from this diagram is that you've got your primary, which is definitive of a key space in Redis. And in this case, we have 2 replicas. You can have up to, I believe, 5 replicas per node. Each replica basically serves that key space. And so if you think about scaling out read performance, you can parallelize that out and really increase the amount of read throughput you have at a pretty large level. And so those are all kind of inherent on when you're thinking about how do I want to structure my MemoryDB database for performance. These are all things to consider. MemoryDB uses the Redis cluster protocol that we leverage the Redis engine. We configure it in Redis cluster, meaning that each node has a bit of a key space. If you have 3 primaries, as you can see on the right, you have a variety of slots that are basically allocated to each primary node, and then obviously replicated on its replicas, and that's how you can scale your cluster out. From a storage perspective, that gives you, I think from a previous slide, over 100 terabytes, 128 terabytes with 1 replica per shard. That the maximum number of nodes in a MemoryDB cluster is 500 nodes, giving you that sort of amount of storage. Supports online scaling and resizing, both scaling out, so adding more shards to scale out your database that way, or vertical scaling, where you take a node, let's say you're running an R6G XLarge, and you want to flip the whole cluster, use R6G 2XLarge. So both of those are supported. And we'll talk a little bit more about some of these features on later slides. From a performance characteristic, and we're going to be publishing a blog with a bit more information on performance soon. But wanted to share just some kind of quick look at what you could expect. So from an R6G 16XLarge, we found that you could have up to 390,000 reads per second, 100,000 writes per second, and from a throughput perspective, 1.3 gigs per second for reads and 100 megabytes per second for writes. So if you think about that, that could be your primary, but then to increase read performance, you can add more and more of these nodes as replicas. So I think you can get up to the cluster size, millions of transactions per second if you scale out your cluster. So once again, useful for incredibly high throughput workloads. One thing that we found customers coming to us saying, well, it's very difficult sometimes to scale these systems. You need to make it super easy to make MemoryDB scale, and also it needs to do this online, that we can't take down this database. Oftentimes, database is going to be fronting high performance applications and serving as a primary database, kind of the foundation for these apps. And so you need to figure out a way to scale in a graceful way so that we don't have downtime. And that's exactly what we make it easy to do. That MemoryDB has a update cluster API where you can just basically say how many shards you want. In this case, example is a MemoryDB cluster with 3 shards, and you can see those numbers in each shard is the Redis key space for each. And there's a simple API. You say, I want to increase my shard count to 5. What happens when you do that is it does an online scale out, meaning that we'll spin up new nodes and start migrating those slots in real time to the new shards that that we're spinning up, but we're not removing read access to the shards while they're being migrated. And so we do it in a way where all of the data is able to be accessed while things are being moved around across nodes. And then once it's done, you've got now 5 shards with a uniform slot distribution across each shard. Similar idea goes for scaling in, that you might say scale out your cluster because you know Q4 might be a heavy shopping season. And if you're running an e-commerce app, you might want to have that extra power across the shards in your database to scale out and handle that spike in throughput. But maybe in Q1, you want to scale back in because you're not getting as much traffic. Once again, MemoryDB handles this quite gracefully. Sunsets the nodes and reunifies the shards across the existing set as well. Once again, just with a simple API call. So fully managed, and very, very easy to do. So we talked a little bit about performance, a little bit about scaling. Let's get into durability, because this is one of, I think, the key differentiating features from Amazon MemoryDB for Redis and other in-memory data stores or Redis. And it's the way in which we ensure no data loss. And once again, going back to what customers care about with a primary database, one of the non-negotiables we found was that you can't lose data. And it's like a binary thing, no data loss. The way that we've constructed this is kind of a similar diagram to the one that I showed before, is that writes, when they come in, basically flow from the primary node. In this case, let's pick one, AZ1 is the primary, to a multi-availability zone transactional log. And this is a separate service. Once again, this isn't like a thing running on each node in your cluster. Whether you have one primary or a primary and 2 replicas, it's leveraging this kind of separate, highly durable transactional log. And that's kind of part of the heart of the database system, that, writes are stored durably there. And so if there is some sort of failure on the cluster, the source of truth is this external durability system that it's using. So when a new node comes back, it knows exactly the source of truth on where to get the data back into memory from. Or when you're thinking about replicas, the transactional log guarantees delivery of writes to replicas, which is different than the way, say, open source Redis would work. In this case, if there is, say, a replication lag from a replica for a variety of reasons, ranging from a network issue to maybe being overloaded from read requests and needing to catch up on the latest state from writes, the transactional log and some of the other logic that we put into the system ensures that each replica will know, kind of how to catch up from that state stored in the transactional log. And actually, as an aside, one kind of, as I'm describing it, you might say, well, what's kind of the consistency model of MemoryDB? On the primary node, it is strongly consistent, that every write that you write to the primary only gets ACKed when it's stored durably, and the primary node always shows the state of the latest kind of ACK data. The replicas are eventually consistent, meaning that the data propagates through the transaction log. But one unique thing is it's guaranteed delivery to these replicas, that there's no real chance of a split brain scenario. Let's say if the primary then goes down in open source Redis, those replicas, that data will be gone, right? Because the primary will have acted, but it wouldn't have passed it on. In this case, because all of that is being held in this highly durable transaction log, it underlies all of the nodes and ensures that the data will be guaranteed propagated to where it needs to go. So once again, a kind of novel approach to, or it's common architecture in many databases, but for in-memory databases, a novel approach to durability and kind of guaranteed consistency over time, making it a great choice for a primary durable high-performance database. When we talk about durability, I kind of like this slide too. It helps think about a little bit of the different offerings in AWS. And we'll talk a little bit about this later as well. But when thinking about the in-memory durability spectrum, AWS offers another service in our in-memory portfolio called Elasticache. Elasticache has a choice of 2 different engines, Memcached, popular caching engine, and also Redis. And when we think about kind of the scale of durability, Memcached has no persistence. Elasticache for Redis isn't durable and is meant really to cache data from other primary databases or serve as a primary database for transient data. It could be that you have a use case where if you did lose data, it wouldn't be a big deal. And there are some of those out there. We call it semi-durable because you can take a snapshot of it, but you can't take kind of continuous snapshots. So it's kind of a point in time durability of the database, which could change. Also, Elasticache has asynchronous replication to other nodes. If you're running a highly available Elasticache for Redis cluster, there's some semblance of durability because you're propagating those records across multiple nodes. If one node goes down, the data's in memory, it gets lost, but the other nodes might have it. The thing is, it's asynchronous, so it's not, with no data loss. And once again, from a primary database perspective, customers demand no data loss. And so that's what kind of, when talking about before, some of the challenges within memory databases push us to build MemoryDB, which is durable. It utilizes this multi-AZ transactional log, and every write when it's ACT is considered durable. MemoryDB has high availability that you can, the durability level, the layer is always multi-availability zone, that no matter how many nodes you're running in your cluster, it's leveraging this durable multi-AZ transactional log. But for availability for your data, as in if you want that shard on that node to be accessible for reads, it's common practice to run replicas across multiple availability zones. And in this case, we kind of talked a little bit about this already. From a performance standpoint, for an availability standpoint, the same thing, that you can add replicas to different zones to scale out performance, and also handle failovers, that you have a primary and a replica, but if something happens to the primary, Amazon MemoryDB automatically monitors and manages it and manages failover. And we can get into that a little bit now on exactly how that works in failover detection. So we'll quickly walk through just a scenario of how failover works, but also this touches upon that point of guaranteed consistency, that with Redis in open source or in Elasticache, it utilizes asynchronous replication, but that can kind of open it up to, in a failover situation, data loss, because the nodes, the records that haven't been replicated from the primary are now gone. However, in MemoryDB, we utilize this multi-AZ transaction log that keeps everything durable, and you'll see here why that's important. So let me just quickly walk you through this example. So in this case, you've got a MemoryDB cluster with, let's say 2 nodes, a primary and a replica. The primary, remember, when a write is committed, let's say a record T, that record, or T is the time of the last executed command. That command is also, the results of that propagated to this multi-AZ transactional log. So the primary and the transactional log are both the same state. In this case, let's say a replica is having some lag. It's being hammered by reads. There might have been some network hiccup where it's 5 commands behind the primary. So in the case of then a primary outage, let's say that there's some issue. The system detects that there's a failover event needed, and needs to basically create a new node and promote the replica to a primary. But as you can see here, the replica still is 5 commands behind, while the the primary node in the kind of application believes that obviously you're at t equals 0, the current state. But the multi-AZ transactional log also represents that. So what happens next? Basically, because the multi-AZ transaction log has the latest state, when MemoryDB promotes the net new node for a primary, it won't actually consider the primary active until it reflects the latest state from the multi-AZ transaction log. And so that's by design, because if the primary, say the replica was promoted to primary and had an inconsistent state, applications that were relying on that primary to be fully consistent will have a wrong version of the data. And so once again, this is kind of why this architecture is important, is that it ensures there's no data loss or consistency issues in these failover events. The MemoryDB obviously spins up a net new replica, and the database now, once again, is operating with a primary and replica with the right data up to speed, thanks to the durability and consistency guarantees of this multi-AZ transactional log. Okay, so moving on. So we talked a bit about performance, availability, how to scale, and durability. Now let's move on to talk about a little bit of what we mean by flexible. We talked about before the idea of a fast, flexible, and friendly database for high performance workloads and microservices. And the flexibility part of that really stems down to the Redis API. Redis is a data structure store, and you're able to leverage a variety of data structures to store data and operations that are specific to those data structures. And there's things ranging from strings to sorted sets to hyperlog logs, a variety of different things that you can do with Redis. There's a bunch of geospatial commands that you can use. And the idea here is that it's a little bit different than, say, the way other databases are data models that they have, making it that you have to do a little bit of learning to understand really the intricacies of it. But once you do, you realize that there's all these different things you can do within the same database that you can build, once again, like a leaderboard, super easy with a sorted set, that you can utilize a bunch of commands on strings. There's all these different things that you can do without needing, say, a variety of different databases to do it. Geospatial, right? You don't need to create or find another high performance database that does radius lookups. You have that all within Redis. And that's super important because it just enables application teams to standardize around one high performance database, but be able to do a variety of use cases or add net new features much more easily because of that flexibility. And we'll talk about it later. Redis is just incredibly popular among the developer community, in part for this reason. Finally, MemoryDB is friendly. We talked about before, DevOps teams love things that are fully managed, easy to use, and MemoryDB has that same standard that you see with other easy-to-use, fully managed AWS databases. That it leverages some of our proven in-memory infrastructure and managing and provisioning clusters. A bulletproof way of doing this, and you can get started in a couple of clicks. It's easy to migrate existing data in Redis if you say want to move from Redis to a fully durable solution like MemoryDB, and can utilize things also like DMS as well to migrate things from databases to MemoryDB as well. So easy to kind of migrate and use. We support the latest and greatest AWS hardware with AWS Graviton 2 instance types. We support R6G and also now T4G, which makes it very, very easy to get started. AWS Graviton 2 has great performance for Redis. It's kind of the AWS homegrown chip technology. Very easy to configure security. A couple clicks, you can configure encryption with your AWS KMS keys, create access control using Redis ACLs. And finally, to use this, there is no kind of special client. It's the open source Redis client. It's the same client that you've probably been using with all your other Redis workloads. In this case, it supports the Redis cluster protocol, and you can use a variety of open source Redis clients. And we've been making some improvements to some of the open source clients as well to make them just easier to use and more robust with MemoryDB. From a friendly point of view, Redis is the developer-friendly database, and kind of the results from these surveys don't lie. That Redis has topped the DB Engine's rankings for key value stores since 2013, and there's a lot of other very popular technologies on this chart, but Redis remains the kind of king of that group for many years. And some of the reasons is because it supports all these data types, it's easy to use, it's incredibly powerful, and it's very, very fast. Redis is also won the Stack Overflow Most Loved Database Award for the last 5 consecutive years. Once again, a bunch of other very popular technologies are on this list, but Redis maintains supreme. And it's just a testament to really the power of the Redis API. And one thing that we're excited is delivering that API as a primary database to customers. Getting connected to MemoryDB, super easy. Once again, you utilize an open source Redis client, and then you configure that client to talk to what we call a configuration endpoint. The configuration endpoint for a MemoryDB cluster basically tells your client where all of the nodes are and all the replicas, and also, as say maybe failovers happen, nodes change, you scale things in and out. The configuration API makes it easy to tell your client where all these things have changed. Once again, super easy to use. And in this case, you can see different availability zones. You launch the nodes in a private subnet, giving it really great network security, and all this networking stuff is easily managed when creating a cluster using subnet groups and things like that to make it easy to create and secure these clusters. Once again, easy to get connected. You utilize the Redis cluster protocol. You authenticate using the Redis ACL. We'll talk about that in a minute. And it utilizes all the open source Redis commands. Right now, we support Redis 6.2, but we will be, enabling you to easily upgrade Redis using service updates as you release support for new versions over time. From a backup restore perspective, we see that there are some customers who are using Redis today as a primary database, but have kind of doing it in a way that they would still prefer to have more of a durability guarantee, or are interested in migrating that use case from, say, self-managed Redis to MemoryDB. Now, once again, many Redis use cases are not going to be right for MemoryDB. If you're using Redis as a cache, then you've got another durable database, and that would be something that you would have a drop-in replacement for MemoryDB for. Where MemoryDB might come in is if you replace, say, a cache plus a database with MemoryDB, because MemoryDB operates kind of as both, that you get the durability of a primary database and the performance of a cache. But we do see some cases where customers, say, are running Redis as a primary data store and just hoping they don't have a bad day where there's some data loss, they have to rebuild the whole cluster, and would prefer to move that to something like MemoryDB that gives all the same goodness of Redis, but that durability. And to do that, it's super easy. There's really two ways. One is kind of an offline way where you can take a snapshot from self-managed Redis or even Elasticache as an RDB file, put it in S3, and then just restore it into a MemoryDB cluster in a couple of clicks. Super easy. If you have more of an online sort of migration where you say, well, I don't want to take this database down, there's a bunch of kind of changes that are happening, I need to kind of gracefully fail over to a MemoryDB cluster, there are some other open source tools that basically enable Redis replication. MemoryDB fully Redis compliant and compatible, and makes it easy to basically run kind of a scan and subscribe on your primary or whatever your Redis cluster that you're running, and then restore it to Amazon MemoryDB for Redis. And there's a bunch of open source tools that can do this in more of an online way. So if you do have a use case and thinking about when would I want to do this, it's that you're running Redis and you say, well, I'd really prefer if my Redis cluster had durability because I'd would prefer to not lose data if there was some event that would happen. Or if you say had Redis fronting some other durable data store and you want to replace that combination with MemoryDB, these could be interesting ways in which to do that. So moving on from some of the backup and restore features, also, one thing I did mention is that you can configure automatic backups with MemoryDB. Obviously, MemoryDB holds the data as durable, but you might want to take backups to, say, restore your database to a certain time or export the backups and use elsewhere. And MemoryDB supports all of that in an easy-to-use automated way. So let's talk about security features. So it's got the usual encryption at rest, encryption in transit, variety of authentications using Redis ACLs, which we'll talk about in a minute. One thing to note is that you can only use ACLs if you have encryption in transit enabled, which we highly recommend to be using encryption in transit, for all of your use cases, with the idea of you should be encrypting everything. One thing to note is that there is a performance penalty on encryption in transit, and there is a mode where you can run kind of true to Redis history with kind of very, very limited authorization and no encryption in transit. But we'd recommend utilizing encryption in transit and ACLs to have high security for your database. Then obviously VPC for the network isolation that you would know. We also support a couple of security-related features in Amazon CloudWatch, where you can see kind of authentication, key authorization failures, commands that were shut down. So you can see if there is some kind of malicious activity happening or just somebody with the wrong permissions, you can start seeing that show up in your CloudWatch metrics, and you could put an alarm on it to say, send an alarm if you start seeing behavior like this. So going back to Redis ACLs, and this is kind of core to how authentication and authorization works in MemoryDB, it's built upon the Redis v6 ACL feature set, where you basically create users. Each user has a password and then has permissions. In MemoryDB, you actually create these at the kind of MemoryDB service level. And so you create basically a user group. Each user group has a set of users. Those users have passwords and permissions. And then when you create a cluster, you say create cluster A and assign user group B to that cluster. And you can change that over time and change users over time. But the idea is that you can create kind of your set of users and then apply those to different clusters as you see fit. This is kind of an example to show a little bit of things that you can do, right? That there's this full access string language where you can put permissions in certain key spaces and commands. In this case, let's say like the user read application is authorized with the get command on certain app keys. And as you can see, this is kind of an example of what the access string might look like in that situation. Marketing has all commands on keys in the kind of marketing key space. Analytics has only all read-only commands, but can't write. If you think about an analytics use case, oftentimes you're not writing anything, you're just reading and doing computation on the fly. This is great for microservice architecture because oftentimes what we see is that customers want to create basically one user per microservice. User isn't necessarily a person, but it's an entity. That microservice has a user that maybe accesses only that key space for that microservice if you have a multi-tenant cluster, and really enables isolation of each microservice in a world where you've got one MemoryDB cluster serving all of those use cases. If you want to learn a little bit more, you can run the ACL log command to learn more in a Redis client. Once again, this is kind of same open source Redis security language that you're used to, but kind of the user creation and management and addition and removal of users of clusters is fully managed by the MemoryDB control plane versus needing to get into a file on each node and update that list of all the users and the commands, which obviously isn't secure and also very, very time consuming. So to close, we talked about a bunch of features around MemoryDB ranging from super fast performance, multi-AZ durability, high availability, security features for multi-tenant users, backup and restore, a little bit about the Redis API and all the things that you can do with it, and kind of giving you a little bit of a deeper view. And one thing that customers have asked me is thinking about, well, that's great, I understand all these features, but you showed me this slide with all these databases, and a couple of them are also high-performant NoSQL databases. When do I use each? That's a great question. I think this is the way that I line it up. Usually I think of MemoryDB, DynamoDB, and Elasticache. And how to kind of think about each one. And the way I think about it is, we want to use MemoryDB when you have incredibly fast latency requirements. When you need microsecond read performance, you're starting to get into, you need a full in-memory database, and single-digit millisecond writes as well. But I think another real big differentiator is just the API, that MemoryDB is a primary database with the Redis API and data structures. And as we've seen, Redis is the most popular database in the world. And these data structures enable developers to build all sorts of things. We support Lua scripting. There's just all these things you can do with Redis to make development easy. And all of that happens with incredibly low latency and high performance once you build your application. And developers have told us time and time again they want to use Redis. And so that's really when you choose MemoryDB, extreme performance and the flexibility and greatness of the Redis API and data structures. With Dynamo, Dynamo is a little bit of a different API. It's key value store. If you have a key value use case, Dynamo could be a great choice. With single-digit millisecond latency, still pretty fast, but very, very easy to scale. DynamoDB is serverless, has kind of more fine-tuned auto-scaling. We see customers really like that who want kind of just this kind of ease-of-use serverless key value store with pretty good performance. And then finally, with Elasticache. And Elasticache also supports the Redis API. We're not talking about Elasticache from Memcached right now. So Elasticache and MemoryDB both offer the goodness of Redis. But I think the kind of trade-off here is Elasticache, on a good side, has microsecond read performance because it doesn't have any semblance of durability. But the difference is that it's really meant for caching use cases that a primary database, you don't really want to have data loss. And Elasticache is not built for that, we really trade extreme performance on writes for durability, making Elasticache a great choice as a cache for another primary database or data store, primary database like RDS, Aurora, DynamoDB, fronting analytics use case like Redshift and caching kind of results there. Great choice for all of those. But where it kind of isn't as great is if you want to use it as that primary data store for durable data. That's where something like MemoryDB is a much better fit, because MemoryDB is purpose-built to be that primary data store. So that's a little bit of a high-level view of when to kind of use each database, what each one is used for. And we'll be publishing more blog content with more use cases to kind of further give more information on where MemoryDB is the right fit. But I think one great example of that is actually coming up right next, where we have Mahesh, who's going to talk a little bit about how they chose and utilized MemoryDB at TSYS for their tokenization service. So I'll hand it over to Mahesh. Thanks.
Thanks, Jonathan. Hello, everyone. My name is Mahesh. I'm part of TSYS Issuer Solutions Group. Few months back, we have implemented a service with MemoryDB as a backend. The objective of this presentation is to share our use case, why MemoryDB was the best fit for our use case, with a goal to make you all think of equivalent or similar use cases within your ecosystem for which MemoryDB might be the best fit. So what's in this session? I'll introduce you to our use case, why MemoryDB was the best fit, how we have implemented HA solution cross-region, what security features of MemoryDB that we have used, the benchmark tests that we have done, and what's next in our journey with MemoryDB. So who is TSYS? For some people who are not familiar of TSYS, I sure can say you all live and breathe our products and services day in and day out as part of your life. Be it as simple as swiping a credit card at a store, checking card balances on your bank's website or mobile apps, or calling a customer service to file a dispute or making changes to your account. We at TSYS are behind each of these interactions. To give you all a bit more perspective about TSYS, we are #1 card issuer in US, Canada, UK, Ireland, and China, and we are the #2 in Western Europe. We process in around 100 plus countries, serving around 1300 plus financial institutions. We process around 50 plus billion transactions per year for 750 plus million accounts on file across the globe. We serve 100 plus vertical industries, including banks, fintechs, retail, and restaurants. We integrate with all major payment networks and channels across the world. So coming to our use case, data tokenization, we at TSYS take data security very seriously, and data security is the #1 tenet for all the solutions that we build at TSYS. As part of that, our goal was to reduce the footprint of sensitive data that we store across all the applications within the TSYS and how we exchange the information between these applications. So how we have solved that problem was by replacing the sensitive data element with a random token, which actually gets stored in the individual application data stores, while the sensitive data token to the sensitive data element to the token information is maintained in one central secured storage area, which we call as token vault. By doing this, we eliminate the need to handle sensitive data at every distributed system and makes the security of the sensitive data tokenizers problem. So based on the scale at which we process, these are the characteristics of data tokenization application. Should be able to store large amounts of data, should be able to deploy this service globally, should provide millisecond latency performance, should be able to handle thousands of requests per second, and the service should be available 24/7, and there is no scope for data loss. Tokenization is the heart of every product and service within the footprint of TSYS issuer solution. This is a snapshot of different services interacting with tokenization. In a nutshell, from an onboarding application to authorization of credit or debit transaction and beyond, each system/subsystem interact with tokenization. The one thing to note is that from data tokenization aspect, majority of these applications are the read-only consumers, while applications like onboarding, customer servicing platforms, and servicing platforms are the only applications that actually creates token data. So let's understand a bit more about the how data tokenization works and what kind of access patterns we have. As you all can see here, we have requests coming through different channels to the tokenization engine. When a tokenization engine gets a request from any of these channels to provide a token for a sensitive data element, it performs a GET call on MemoryDB to see if a token already exists for the sensitive data element on MemoryDB. If it exists, then it prepares the response and returns the token data to the client. If the call doesn't return a response, we generate a new token using our internal tokenization algorithm and make a MemoryDB set call to store the sensitive data to token mapping durably. Also, at the same time, we also ingest the data into Kafka. We will see why we do that in the next coming slides. Now that we have discussed about the characteristics of our tokenization service and how every application within TSYS interacts with it and what access patterns we have, these are the very important non-functional requirements that the backend data store that supports tokenization should satisfy. Number one, it should be able to handle large amounts of data, should be able to store around 4+ billions of token. And the data store should be available 24/7, should be durable without any data loss, should provide a very high throughput at around 100K plus read IOPS and 10K plus write IOPS at a millisecond latency. So why MemoryDB, right? MemoryDB provides us performance at scale by handling thousands of requests per second, and it does provide single-digit millisecond latency. And it does provide zero data loss durability. And being a managed service, there is no need for us to worry about like administration of the servers. Instead, we can focus on building our application. And MemoryDB does provide managed scaling through API, and it does provide on-demand capacity mode. And being the nature of data that we store, security is very important for us, and MemoryDB does provide encryption at rest and transit, and also Redis ACLs. And it also provides on-demand backup and restore. So the next question which everyone will have in their mind is, why only MemoryDB? We also have other options in the AWS data suite, like Jonathan shared before on the purpose-built data store slide. There are two other databases that we have evaluated for this use case. Number one was Elastic Cache for Redis. It provides us everything except for the data durability, which is very important for us. And the second data store that we have evaluated for this use case was DynamoDB. It does provide everything, and it was the best fit for our use case. But as we are migrating this service from our on-prem, where we have implemented this service on enterprise Redis, migrating to DynamoDB will be a huge change from the application point of view. So this is where MemoryDB, as it's 100% compatible with Redis API, it's undoubtedly the best fit for us. So this slide shows how we have implemented high availability with MemoryDB across regions. As mentioned earlier, our applications are read intensive and the writes are done only by a handful of services. We had two problems in our hand. One is to scale the reads cross region, and number two is to sustain any regional failures. As MemoryDB doesn't support global clusters or cross-region replication yet, We have implemented a HA solution by leveraging Kafka to asynchronously sync data between two MemoryDB clusters in different regions. As you can see, every new data element that gets inserted into MemoryDB is also ingested into Kafka, which gets synced to the secondary region where the tokenization consumer consumes and applied to the secondary MemoryDB cluster. This implementation pattern helps with solving both the problems at hand. So coming to MemoryDB security, as ours being a multi-tenant system where we process for around 100 plus clients, one way to architect multi-tenancy is by creating a separate MemoryDB cluster for every client and manage the tenant separation that way. But that adds a lot of overhead and a maintenance nightmare. So that's not the direction that we want to go for. So we needed to support all the clients from a single data store, and at the same time, we should make sure there is a tenant separation built in within our system. That is where Redis ACLs come into the picture, where it provides the capability to limit the action that a certain user can perform and the keys that user can access. This is an example on how you can set access rule for a user, where you define a username and set an access string with all the action that a user can perform and what keys he can access. So this is where like a Redis ACL came into help for solving the multi-tenancy aspect. And by now, you all know the nature of the data that we store in this database. So without saying, encryption at rest and transit are mandatory, and MemoryDB does provide us with the both. Coming to the performance testing that we have done on MemoryDB, our objective for the performance test was to identify the ideal instance type and the shard setup for our throughput and latency requirements. We had set up our testing to be 19% reads and 10% write requests. This is the setup for our test where we have 200 concurrent requests from 10 threads with 20 connections each, and with each connection making over 10K requests. So here are the throughput results for a cluster setup of 3 shards with 2 replicas each. We have tested with 3 different instance types, and mostly every instance type provides more than 200K plus read IOPS and 10K plus write IOPS. And as you all can see, R6G4X large instance type seems to be a bit better out of all the 3 instance types that we have tested for our use case. And similarly, we see a latency of around 7 to 8 milliseconds for writes and around 1 to 2 millisecond latency for reads. So by saying all that, MemoryDB was a good success for our tokenization use case. And now we want to try MemoryDB for other use cases that we have at our hand. So number one use case was we want to use MemoryDB as a data store for our enterprise program configuration management. Over there, we want to manage our enterprise configuration data in the MemoryDB. And other use cases where we want to use MemoryDB was like using MemoryDB as a cache for our application state, and also use it for like a session state store for our web and mobile applications. That's all I have for this presentation, and thank you for this opportunity, and we'll be giving over to Jonathan.
Thanks, Mahesh. For more information about MemoryDB, please visit the MemoryDB website. Thanks again for joining our presentation, and catch you next time.